lesson 1, rolling, rolling, rolling. Let's go ahead and turn the page to our getting started. What are the chances? Consider each statement. Number 1, the local weatherman broadcasted that there is a 40% chance of rain today. A says, in your own words, explain what this statement means. So basically, for A, if you were getting ready for school and you heard on the news, there's a 40% chance of rain. What does that make you think? What does it mean when the weatherman says there's a 40% chance of rain? So let's talk about B. Rewriting this sentence, but instead of 40%, what would that be as a fraction? And then Ariel, what did you say?
40 over 100.
40 over 100. I'm not going to rewrite that entire sentence just to save us some time. But that's perfect. Percents are out of 100. So to write a percent as a fraction, simply write it with 100 in the denominator. Is this the only fraction that we can write that's equivalent to 40%? 4/10 is correct as well. 4/10. Because 40 and 100 can both be divided by 10 to simplify to 4/10. Can we make any other equivalent fractions for 4/10 and 40/100? 2/5. Fantastic. How'd you get 2/5?
Divide.
4 and 10 can both be divided by 2, and we get 2/5. That is an equivalent fraction. Fantastic. So let's go ahead and get into the meat of this lesson. Activity 1.1. Activity 1.1. Calculating simple probability. A six-sided number cube has one number from 1 through 6 on each face. Number cubes are often used when playing board games. What is a six-sided number cube? Have you ever used a six-sided number cube?
Wait, is it cubes that like when you play board games? Yeah. Oh. It's basically a dice.
It is a dice. Six-sided number cube is the fancy way of saying dice. So anytime you see six-sided number cube, your brain, that's a dice. But using our academic vocabulary, we're going to say six-sided number cube.
That's also fast.
It is. What about face? Number cubes have faces. Are they pretty faces?
No, they're numbers. Well,
They're numbers or they're sides. Face is the mathematical fancy way of saying side on a 3D object. So, number 1, create a list of all the possible numbers that can appear on the top face if you roll a six-sided number cube. 1, 2, 3, 4, 5, 6. That's it. A list of all the possible things that our number cube could land on. Okay, here's a long paragraph, but some important vocabulary terms. Yes, go ahead. Thank you for volunteering.
The numbers on the faces of a six-sided number cube are the outcomes that can occur when rolling a six-sided number.
Okay, pause. So underline this word outcome. That's going to be our first vocabulary word. The number of faces or sides are the outcome. Yeah, now go ahead.
An outcome is the result of a single trial of a probability experiment.
Okay, pause. So, this sentence, an outcome is a result. Circle the word result because that's what outcome means. An outcome is a result. What could happen? So, anytime you see outcome, it just means result. What's a result? Okay, now go ahead and continue.
An experiment is a situation involving chance that leads to results or outcomes.
Go ahead.
A list of all possible outcomes of an experiment, experiment is called a sample space.
A sample space. So, underline or highlight that last sentence. A list of all possible outcomes is called a sample space.
They gave us the definition on the side.
They did give us the definition on the side. And actually, this is very important. We're going to need it when we answer number 2. Thank you for noticing it. A sample space is typically enclosed in braces that look like this, with commas between the outcomes. Also, I need you to circle this, a list of all possible outcomes. A sample space is all of them. So really, we've already listed a sample space. Number 2 says list the sample space for the experiment of rolling a 6-sided number cube. We already did that. Because the sample space is all the possible outcomes, all the possible numbers that the number cube can land on. 1, 2, 3, 4, 5, and 6. Now we know that we can use, or that we use those little brackets to make it more academic. So far, outcome is the result. Sample space is a list of all of those outcomes with fancy little brackets around it. Go ahead, Ariel.
An event is one possible outcome or a group of possible outcomes for a given situation. Event is an event consisting of one outcome. For example, in the number cube experiment, an event could be rolling an even number. However, rolling a 5 is a simple event.
Great job. Yep.
They even have the definition of the 5.
And again, we notice over here, an event is a subset of the sample space. This fancy word subset just means part. An event is part of the sample space. For example, rolling an even number. What's an even number?
Like 4, 8, 6.
2, 4, 6, 8, and so on. How do we know a number is even?
Because if you split it in half, it'll have the same amount on each.
That is a great definition. If you split it in half or divide by 2, it is not a decimal. It has the same on one side as it has on the other. It is evenly divisible by 2. Look at y'all go. And then, let's see. Rolling a 5 is a simple event because how many 5s are on a number cube? 1. So, next paragraph. Go ahead. You can read.
Probability is a measure of the likelihood that an event will occur.
Pause. So, underline this sentence. Probability is a measure of the likelihood that an event will occur. Likelihood just means the chance. Probability is the measure of the chance that an event will happen. Occur just means happen.
Wait, no, that was the getting started.
But you're right. That is why the getting started was called What Are the Chances? Good connection. Because probability is the chance that something's going to happen. Numerically, what's the probability or what's the likelihood that something will happen? Go ahead and continue reading.
It is a way of assigning a numerical value to the chance that an event will occur. The probability of an event is often written as P, or event.
Okay, pause. So, probability is a pretty long word, and it would take a while to every single time write out probability of rolling odd or probability of rolling a 5. So instead of having to write it out, we abbreviate it to look like this, right here. What do you think the P stands for?
Probability.
Probability.
So, is probability kind of like making an inference?
Yeah, making an inference, making an educated guess. Because we can't really tell the future.
Oh, wait, we do that all the time.
Y'all do that all the time. In science class, right? And in reading class, when you're reading and you're trying to guess what's going to happen. Y'all are making some great connections. I love it. So go ahead and continue reading.
For example, in the number cube experiment, the probability of rolling a 5 could be written as P5.
Yep.
The probability of rolling an even number could be written as P even.
Thank you. So this last couple of sentences was basically just letting you know what this abbreviation means. Anytime you see P and then something in parentheses, it's asking you to find the probability of whatever is in the parentheses. What's the probability that that will happen? And then this last part down here is how we find that probability. It is the formula. This is how we set up probability. We make a fraction. On top of the fraction, in the numerator, we put the number of times an event can occur. So that would be like how many 5s are on the number cube, or how many even numbers are on the number cube. You're looking at what's in those parentheses. On the next page, we'll do some examples. The denominator is the number of possible outcomes. It's the number of all outcomes. The total number of outcomes. On the next page, we're going to start practicing this. We're going to look through a worked example. And before we look at it, I do want to tell you, we're going to kind of change the wording of it because I want to make it easier on you. Y'all know how Carnegie can get. So let's go ahead and turn the page. Up at the top, page 518, this worked example. To determine the probability of rolling an odd number, well, first, what is an odd number? Like 1, 3, 5, 7, and so on. It's the opposite of an even number. So to determine the probability of rolling an odd number, or P parenthesis odd, follow these steps. These steps, I'm going to change some of the wording just to make it easier. So for step 1, list all the possible outcomes. That's it. Just list all the possible outcomes. So if we're talking about a number cube, what would all the possible outcomes be?
All the numbers.
All the numbers, which are what?
1 through 6.
1 through 6, so we're going to write all of those. 1, 2, 3, 4, 5, 6. Step 2, we're not going to add the numbers. Mark that out. Scribble it out. I don't want you to get confused. You're not actually going to sum the numbers. We're just going to count. We're going to circle. Circle the number of outcomes in the event, or for the event. Circle the number of outcomes in or for the event. What are we finding the probability of?
An odd number.
An odd number. So we're going to circle all of the odd numbers. 1, 3, and 5. So there are 3 possible outcomes for rolling an odd number. 1, 3, and 5. 1, 3, 5. There's 3 of them. We're not adding 1, 3, and 5. There's just 3 of them. Now we can go to step 3. Use your equation to determine the probability of rolling an odd number. So P, probability of odd, equals the number of times an odd can occur. So there were 3 odd numbers on the number cube, 1, 3, and 5. The denominator is the number of possible outcomes. That's the total. How many total faces were on the number cube? 1, 2, 3, 4, 5, 6.
So 6 divided by 3?
3 divided by 6. 3/6. So the probability of rolling an odd number is 3/6 or 1/2.
Because in that situation, the top number is in and bottom number is out.
Yes, because if you didn't already know, oh, yes, I see what you're saying. So if you wanted to change it into a decimal, you would divide top in, bottom out. You're correct. So let's practice. Let's do a practice. Number 3. What is the probability of rolling a 4? Or, that's how we would write it mathematically. The standard form-ish. Because we're just learning how to do this, I'm going to write out the steps. So step 1 is to list out all the possible outcomes. Well, yeah, let's not write the words. Let's just write them. So we said 1, 2, 3, 4, 5, 6. List out all the possible outcomes.
Circle the number of outcomes in the event.
So step 2, we're going to circle all of the 4s. What'd you say?
There's only one 4.
There is only one 4. So we only have to circle one number. 4. Yep. Step 3 is now we're going to use that format, that equation, to get our probability. So the probability of rolling a 4 we're setting up a fraction. The numerator represents how many 4s there are on the number cube. There's only one 4. So there's one 4. I wrote out 4, that way we didn't get confused and think it said 14. There's only one 4 face. What's the denominator represent?
How many faces are in the cube?
How many total faces are in the cube? Great use of vocabulary. And what would that number be? 6. So there's, or total faces. I was going to put total faces, but you can put 6 faces. You could also put 6 total outcomes, 6 possible outcomes. And that's it. So the probability of rolling a 4 is 1/6. Yep. So to determine the probability of getting a 4, consider how many times a 4 can occur when you roll a number cube, a 6-sided number cube. That's the numerator. So you try number 4. You try number 4. What's the probability of rolling a 6